Back, everybody. We're back at the Pontiac rebuild, the 350. Now, in the last video, we did the short block assembly. Also, what I've done is I installed the cam bearings and the camshaft. I'm not sure if I put the cam bearings in on camera or not, but that's kind of a machine shop deal, so you really don't need to concern yourself too much with that. Most of you are not going to be putting the cam bearings in. Just have a machine shop do that for you. Then you want to test fit the cam, and you want to make sure that that cam rotates easy. So this cam rotates real nice. There's going to be a little bit of resistance there, but it shouldn't be tight, and it shouldn't be binding. It shouldn't be binding or tight. This one turns really nice. The next step is we want to put our timing chain and gear set on. We got a performance double roller, heat treated, pre-stretched performance chain for this thing. Now, before you put the chain on, you always want to make sure that you have your oil gallery plugs in here. These are your oil gallery holes, and there's some plugs that go in here, and you got to make dang sure that these are in before you put your timing set on, because I've seen guys put their timing set on and they forgot about those plugs, and once the timing chain is on here, that hole is out of sight, out of mind, and they forget. And then when they go to start the engine, they don't have any oil pressure. Really important here that the gallery plugs go in. Most of the time the machine shop will remove those to vat and clean the block, which is exactly what we did. So I'll show you the plugs, we'll get those in, and then we'll put our timing set on. Alright, so now we've got our plugs in. These are just a couple of small core plugs that come in your kit. I just take a bolt that fits right inside there, the head of a bolt that I'm not going to ever use again, and I use that to drive those in. Also, very important here, you guys, the factory swedges this hole. You want to take a punch and you want to swedge the edge of that hole in 3 or 4 places. It's just a little extra insurance to make sure that those plugs don't pop out, because there is oil pressure behind those plugs. I've actually seen these come out when guys did not swedge the hole this way. I've never seen one come out when the edge of that hole is rolled over or swedged. And they've been doing them like that since the 1950s in these Pontiacs. The factory swedges those holes and they don't come out. So as long as you swedge your holes, your plugs are good. Now the next step is the Pontiac has a retaining plate. Now keep in mind there's an oil groove right here, you can see it. The oil hole and the groove on the retaining plate has to line up with that oil groove. So this groove here, you can see there's a hole and a groove cut. That groove goes to the back. It goes toward the block or toward that groove, and the hole you'll see facing forward. So that plate goes on there just like that. As far as your bolts go, it's always a good idea to use Loctite on these threads. You don't have to, but I do it just as an extra precaution, just because I don't want these bolts coming out. So get a little Loctite on there, get your bolts started, and then of course we want to torque our bolts to 25 foot-pounds. Want to make sure these are not loose. Once you get them torqued, now your plate is on, and we can talk about putting your gear and your key in here. Alright guys, so our next step is we have this aftermarket Milodon windage tray that we're going to run. Milodon provides 4 special studs and also 8 of these nuts. If you just set the windage tray down on there without these lower nuts on here, it's going to hit the crank. So the best way to do this is you just want to run this down so you have a little bit. I mean, they have instructions to tell you how to adjust it, but I've done so many of these that this is basically the best way. You run it down till you just have enough of a stud sticking out so you can get the upper bolt on, and then you basically lay your tray on there, okay? And you can adjust these, and you're going to have to tighten these up. You're going to have to get a wrench on these and tighten these up. So you put your windage tray on, and then you run the upper nuts down on that stud. Don't tighten them up just yet. You may have to adjust that stud. So I've got to go down a little more here on a couple of these. This one has to go down a few more turns. So you want it just like that, so you've got enough of a stud sticking out there that you can bite onto it. And you're going to run this down. Once you get those on hand tight, you want to rotate the crank and make sure the crank is not hitting this. You also want to visually check and make sure you got plenty of clearance in there. This one looks really good. It doesn't look like I have any issues. Once in a while you'll do one of these, depending on the crank will hit the windage tray. Yeah, we got all kinds of room in there on this one, so we're good. Then you want to torque these fasteners to 40 foot-pounds. If you have a long 9/16 wrench, it really helps, because you're going to have to get in on that lower bolt there. 40, and you're in business. Alright, get the torque to 40. Now, we've pulled that down slightly. You want to rotate the crank again, make sure you don't have any clearance issues. Yeah, we're good here. We're not even anywhere near close to that windage tray with our crank or our rods, so we're good. Then you want to test fit your pan without the gasket on it. We still have to put our oil pump on, but that's a separate issue. You want to get your pan on here and make sure that your pan is sitting down flush on the block, and that windage tray is not holding it up at all. Okay, this one looks really good, and we don't even have a gasket on there, and it's sitting pretty much flush on the block, so we're good to go on that. Okay guys, so off camera I went ahead and put the ARP studs in the block. I just stuck the head gaskets on there for now. They go on these dowel pins here. This is a roller cam. One of the next things we're going to do is we're going to degree the cam. So I've got the cam card here. If you do degree the cam, you want to make sure, you want to avoid using the lifters. These are the roller tie bar lifters that are going to go in here. You want to avoid using those if possible. Get yourself one of these gauges. The reason is, I mean, it's okay to use these if you have a solid lifter, but this is a hydraulic cam. And also on your tool, you can buy, I bought this at Summit Racing. They have two different ends that go on here. If you're doing a flat tappet cam, you're going to need the end that's flat, that looks like that one, like the one hanging up there. If you're doing a roller, you want to make sure you put the rounded edge in there, or the rounded end in there, and that goes in. It has this rubber piece in here and it locks in place, and we use that for degreeing the cam. I've done some other videos where we're degreeing the cam, and we'll use a bridge gauge to find TDC and so forth. Unfortunately, I was going to degree the cam today and do the video. Unfortunately, the timing chain set that we have is wrong. It didn't, I'm not sure what it's for, but it's not for a Pontiac. So it's Saturday, and when you're working on a Pontiac, you are not going to find anything for that motor on a Saturday night. So I'm going to have to get a hold of EPW or a Summit or somebody and get the right, exchange that chain set. So what I want to do is I want to take a look at the cylinder heads now. Now, as you can see, the heads look a lot different than they did when we pulled them off of the engine. We had these thermally cleaned, and I also pulled it. They had press end studs in here. I also pulled the press end studs out of here. Now, what's kind of interesting is the Pontiac has solid push rods in some cases, and they have studs that have an oil feed hole, and there's oil comes up and actually feeds the rocker through the stud. Well, we're going to eliminate that. We're just going to use push rods that are hollow, and we're going to go ahead and tap these and put screw-in studs in them. Now, what's interesting about this is if you buy the stud kit for a big block Chevy 454, 427, whatever, 396, the studs work perfectly to replace the Pontiac press-in studs. Of course, we're going to have to set these up on the machine and tap all these holes, and then we use a 7/16 stud for the rockers, a screw-in stud for the rockers. We're also going to set these up. I'm going to move everything over to the cylinder head shop, set up the camera and stuff over there, probably really quick here, because I think we're getting ready to work on the heads. I'm kind of at a standstill on the block because I don't have the timing chain. So we're going to put valve guides in here, and you can see that the valve bosses are really thick here. We're also going to cut these down for a positive type seal. And now the valve springs that we have is a dual setup, and I mean, there is no way this spring is going to work with that and get a seal on there. So we actually have a special cutter. We have to cut the diameter of this boss down, and we also have to cut it lower so that when our bigger lift cam opens the valve, the retainer doesn't smash into this. These are actually too tall here. So we're going to cut this way down and make it smaller, and we're going to use a special seal that goes inside this inner spring here, because we're putting our roller cam has a dual spring setup on it. So we got quite a bit of work to do to the cylinder heads. I'm not going to film all of it because that would be like the most boring video ever, but I'll give you a real simple tutorial of what we're doing. The heads did MagnaFlux good, and these are the original 350 heads. We actually wanted to go with an aftermarket head on this, but they all have bigger valves, and unfortunately they were hitting the cylinder because of the small bore on the 350. It just didn't work out. So we're going to stick with the factory heads. It'll still run decent, and it'll be original as well. So all right, so I'll get these set up over there, and it's probably going to take an hour or two before I get everything going, but you won't know that. It'll seem like it's instantaneous. Okay, we're back over at the cylinder head shop. So we've got the heads up on the machine now. Everything is referenced off of the valve guides. So the first thing you're going to do when doing any kind of machining is we're going to level up the machine here, and these are integral or integrated guides, and so we're going to bore those out of there. This is a core drill, and I've kind of talked about some of this before. This pilots into the existing guide, and then we're going to go ahead and bore that out to a 1/2 inch and then ream the hole. And we have a replacement thick wall guide. You can see that pilots into the existing hole. We have a replacement guide that we're going to press in there. The guides are very loose on these heads because, I mean, obviously they got a lot of miles on them. So we can put a gauge in there, but if we just put our valve in here, you can see the movement there. These guides are they're just high mileage, and they definitely got wear. So we're going to go ahead and bore those out, and then we'll press new guides into these heads. Alright, so we've got our head leveled up here, and now I'm not going to put all of the guides being drilled out and installed on camera. That would be really super redundant, and you guys would lose interest, but I'll do a couple here, or maybe just one, so you can see how this goes. So this is an air table, and it moves once we hit the pedal. So we just put our core drill, now that it's been leveled. I hope that cooler's not too loud, but we're in the Southwest, it's hot outside. I gotta have the cooler on. It's nice in here with the cooler on. So we just pile it into our hole here with our core drill, and it doesn't matter where you start, you can drill any one of them out. So now that we've got that piloted up, we can just go ahead and bore that guide out of there. So we are literally just boring that out. so we got through it. The next step is we have to ream that hole because we're taking a large amount of material out, and in order to fit that guide to a press fit, the hole's actually too small. If we ran it right to size, taking this much material out, the hole would end up being too big. So we have to hog it out with the core drill, and then we got to ream the hole to size. And of course, we're going to ream the hole to size with a reamer. This only takes out about 1 to 2 thousandths, somewhere in there. So we're fine tuning that, and it actually makes the bore that we're producing about 2.5 to 3 thousandths smaller than the diameter of our guide, because we have to press this in, that way it doesn't fall out, you know, when the engine's running. Get a nice ream on that hole, and now we can use our air hammer and drive that guide in there. So this is our old valve. We're going to put new valves in it, but I don't have them yet. So that is an 11/32 guide that we're going to press in there. So we oil up that hole, and we have an air driver that we're going to use. We're just going to go ahead and drive that guide in. So you can see now we've got that guide driven in there. We still got to get all the chips out. But now that the guide is driven in, we can go ahead and finish it. And we have restored the clearance here. All right, guys, so for purposes of demonstration, I've only done one of these. This is that guide. I've rotated the cradle around now, and you can see our guide up here. And again, we're gonna level the cradle because we have to cut that guide now. So once we get this leveled, we lock our table down, so she doesn't move. Alright, we've got this guy leveled. Now it's off a little bit. There we go. We got the cradle locked, we got it leveled. Now these guides are universal, so it's actually longer than it needs to be. It's just a bulk type guide that we buy in boxes of 100, but it's the right size. So obviously we're going to have to cut this down. Not only that, we talked about the boss here, how that it's way too big for that dual spring setup that we're using with our roller cam. So we're going to have to cut those down. So this is what's known as a PC cutter, or a positive seal cutter. Not only is it going to trim the guide diameter, but it's going to finish the top, and we can trim it down to where we need it to be. We just move our cable where we need it. Once we get lined up with our tool, we know the head's level and we go for it, we start cutting. So I took some measurements off camera, and the cam that we're using, so according to my calculations, I need to cut about 80 thousandths off of the height of that. So my height here is 640 thousandths. So I need to cut that down to about 550 thousandths above the spring pad in order to make the new camshaft safe. So that's what I've got the machine set for. So we'll go ahead and start cutting this one. You'll see it'll trim the guide down, and then we'll get our height there. that is where this guide started. You can see how we've trimmed down the OD of that in order to get a better seal inside that inner spring. So we're basically back where we started, where the top of this is, but we're going to take a measurement just to verify that. So we'll get our chips out of here. We always want to verify our measurements. The machine's pretty accurate, but so yeah, that's the same height right there. So I'm right there at the original height of the guide, and now I need to go down 80 thousandths. So I've got the machine set at that point for 80, and we just go down till we hit our stop, and that's going to put us where we need to be. So I'm just using stacked feeler gauges here to set my height here on the stop on my machine. That's 80 thousandths worth of feeler gauges. So we set our stop now. Now we can cut her down another 80 and we'll be in business. Alright, so we're just going to double check our height here and make sure we're where we need to be. That is about 85 thousandths below what the height of this is, which is close enough. 80, 85 thousandths, 90, whatever. So that's right where we need to be. I've got the machine set for that height all the way across. So now I can just go ahead and cut them all. Like I said, I'm not going to do all that on camera and bore you guys to death, but I'll get that done. Now, another thing is the screw-in studs here. Now, the Pontiac has this wimpy little guide plate that they have on there, and it bolts onto the head. So if you know anything about the Pontiacs, there's a couple of holes here, and this thing just bolts on here, and they use this as guide plates. Listen, when you're using roller rockers, so we're going to a really nice full roller rocker here on this engine. These things are not adequate. You need to throw these in the trash. So, you know, anything that's worth doing is worth doing right. What you need to do is get some hardened steel guide plates. A lot of people make them. We got them from Comp. And those are going to go along with our new screw-in stud. So instead of press-in studs, we're going to put screw-ins in here. So we have to tap these holes. Now the nice thing is the Pontiac uses a 7/16 stud, which really stabilizes that valve train. The small block Chevy and Ford, they use a 3/8 stud. Having a 7/16 stud on the rocker really stabilizes the valve train, and it makes a big difference. So this is the same size stud as a big block Chevy or a big block Ford. So this is really going to be a definite upgrade for this valve train. So okay, so I just tapped this one, guys, with my half 14 tap, and it's a little time consuming to do this, so I'm not going to put it all on camera, and basically this is going to be our hole for our 7/16 stud, but of course we're going to have a guide plate on here. Alright guys, so we've got the guides in, got the guides trimmed down for the seals and the height, and we got all of our screw-in stud holes tapped. As you can see, we got all the guides in here, and now we need to start looking at these seats. So the guides are installed. I do need to vacuum some of the chips out of there. I didn't get around to that. Now, one thing I want to say here is these guides that I'm using, they have a, I'll show you this, you can see that on camera. If you look in there, you can see that there is a spiral groove in there. Right inside that guide. They have a spiral oil groove. It doesn't go all the way to the, it goes down about that far. And I want to talk about this because I know earlier when we put that guide in, I watched the video and you could see that spiral in there. And what always happens is I get somebody that jumps on their computer and sees that groove in there and writes me a 300-word message in the comments about how that I shouldn't be knurling guides and I don't know what I'm doing. This is a knurling tool. Okay, now this has its place on some heads where you want to do a cheapy job. The customer doesn't have any money, you want to tighten up the guides. This goes in there and you run this down the guide, and what it does is it cuts a spiral in the guide, and it pulls them. If the guide is loose, it's going to pull the metal out and make the guide tighter. It's the way you do like a budget deal, and we do this sometimes just to freshen up heads so they can get another year or two out of them, or they can sell the car or whatever. And I understand this is a budget thing, but don't mistake the fact that these replacement thick wall guides have a spiral in them. That is not a knurl in that guide. That is an oil spiral, and it's very shallow, and it's just designed to keep the lubricated. So for those of you that are going to jump on your computer and, you know, educate me on what an idiot I am, just keep in mind it has new guides in it. They're not a knurl. Okay. All right. So I want to get that out of the way because I've had that happen 3 or 4 times with this type of guide. It just, there's always somebody that has to tell me how dumb I am, right? What an idiot I am. Now, I have my moments. If you want to know whether or not I'm an idiot, my wife at times would probably agree with that. So, because I can be. Nevertheless, we did put new guides in these heads, and they are not knurled. So, now we need to start looking at these seats. The exhaust seats in the early Pontiacs were not hardened. They are just a cast iron integral or integrated seat. When it comes to the issue of these exhaust seats on the factory Pontiac cast iron heads, I do not recommend that you put hardened seats in any of these heads. I've done it before. I have hit water, even with the shallowest of seat. Once you're cutting that, you cut into the water jacket. With the factory Pontiac heads, it's not a good idea to put hard seats in it. And there are other sources that back me up. There's a company back east called Nightmare Performance, I believe. I've dealt with them a few times, and they specialize in nothing but the factory Pontiacs. And he concurs with me on this. He says he would never put hardened seats in because he's had the same experience I have, and they specialize in nothing but Pontiac. What I recommend, and what a lot of people recommend, is Joe Gibbs. It's not really Joe Gibbs anymore, but it's called Driven. They have what they call an additive called Defender Booster, and I would recommend, in fact, I make it mandatory, like in an engine like this, I want my customer to run with every gas tank a half a bottle of that Joe Gibbs or that Driven Defender Booster, and what that protects the valve seats. I've been using it for many years on these Pontiacs, and there's a few other engines out there that I don't like putting seats in. Some of the Fords, the bigger Fords, I don't like to do it. That, you know, that's just the price of doing business if you're going to run one of these early heads. Especially when you're hot rodding and you're running it kind of hard. We're going to put stainless valves in here, and that does help a lot. But in order for that valve not to pound or beat that seat in, you got to put that lead additive. Not only that, the Defender Booster, what I've noticed, I use it in some of my older vehicles, and it really helps keep the carburetor clean. It also, one of the things that we have nowadays is the gasoline is just terrible. It has additives in it. It has too much alcohol in it. It just corrodes fuel lines and carburetors and venturis and all kinds of stuff. It causes trouble. That Defender booster really fights against that. And so that's what I would recommend, and that's what I'm going to have. That's what we're going to do in this situation. So one of the other really important checks here is we're going to use a straight edge. This is a Precision Machine straight edge. And we're just going to lay it across the head, and we're going to take the appropriate feeler gauge and make sure it doesn't slide. Now this gauge is not sliding, but you also want to go diagonal like this. And what we noticed here is when we went diagonally here, we got a little bit of movement here on our feeler gauge. What that tells me is that the head is actually twisted, which is not unusual for these. Even though we don't have any signs of overheating or warpage, we are showing some twist here, which is going to require that this head be resurfaced. We were going to surface them anyway, but we're just going to skim cut this. We're not going to take too much off because it changes the compression ratio. And also, when you shave the heads and mill the heads, you have to take the same amount of material off of both heads so that these chambers end up being the same size. I've got the other head set up over there, so we'll walk over there and I'll show you what that. So in order to correct the imperfections on the deck of the head and also give it a better finish, we set it up on a milling machine. This is what we call a rotary broach machine, and it works really good on the earlier cast iron heads. For some of the later aluminum stuff, we have a different machine. It has a different type of cutter. But basically this, we level the head. It's held on the machine with these fixtures here. We level the head, and then we just let this rotary broach feed underneath the head, and it shaves or mills the head. It does a really good job. This machine will take off 5 or 6 thousandths at a time, but I'm really user friendly. I only take 1 or 2. I don't want to tear up my tooling. So, but the nice thing is I don't have to stand here and babysit it. I can just let it run. I've got the guides and the tapping and everything done on the other head, and it's ready to have the seats worked on it. So while this runs, we'll go over to the machine and I'll show you how we do the valve job or cut the seats. So we've got our cutter set up. I took one of the old valves and cleaned it up, and I reconditioned it. I put it on the grinder. We're not actually going to use these valves, but we're going to use the same size valves. So we use this in a fixture to set up our tool so that our 45-degree angle on our adjustable tool here is right in the center of that 45. I've already cut one. I'm going to go ahead and cut another one here just for demo purposes. And this has multiple angles on it. So we're actually doing a 4-angle valve job here. This tool has 4 angles on it. So just put our tool on, and we locate the head underneath the driver, and then we go ahead and cut it. That's really all there is to it. We're not really taking much off. We're just truing up the seating angle, which is 45, and adding another angle below it and 2 angles above it for better flow. And that is what we call a multiple angle valve job. It's actually kind of hard to tell on camera, the multiple angles. They're very small there, but that is how we do our valve job. We got our guides in. First of all, everything's referenced off the guide. We talked about that earlier. I'm going to go ahead and cut all the seats, and then we're going to thoroughly wash the head. And once we get our valves, we can talk about checking the seating of these and reassembling the cylinder heads, setting up the springs and so forth for our cam. Also, another thing that I want to point out on these heads here, and I'm not sure why Pontiac did this, but on some of their heads, you can see you've got your exhaust manifold bolts here, but they didn't drill this. On most of the bigger performance engines, these were all drilled, but on some of the 350s or the lower performance engines, they didn't drill this extra bolt here. Listen, you have got to drill those. I'm going to request the headers from the customer and bolt them up and lay this out. When you're running headers, you've got to drill this hole and tap it for a fastener. My advice is have a machine shop do it. We're going to set it up on a machine and lay this out and do it. And we definitely want to get the header that's going to be used. But yeah, these end holes, they put the boss there, the pad there, but just at the factory they did not drill them. So I'm not sure what the Pontiac engineers were thinking. I don't know if they were smoking dope or what, but those bolts need to be there. Alright, so I've gone through and I went ahead and cut them all, and they look good. Later on, of course, we're going to have to clean these heads up. When we cut these seats, we don't take a whole lot off. We're just truing up the angles that are there and making sure there's no imperfections or pitting. And of course, I reconditioned a couple of the old valves here. And we can kind of slam this up against that seat there. And you can see where the seat is. I don't know how well the camera's going to pick it up, but I'm right in the middle of that 45, which is perfect for where I need to be. We're going to bed these in later, and again on the exhaust I'm right in the middle with the 45. We're going to go through a lapping process later and bed these in to really make sure that all the imperfections are off of it. But that's basically your valve job. I think I'm going to end the video there because I'm approaching 30 minutes or more. One thing I've noticed from my analysis is when I get past 25-30 minutes on these videos, my audience nosedives. Everybody just quits watching. So 30 minutes is about as far as I want to go, but we covered a lot in this. I appreciate you watching. When I come back, we're going to do a little more on the bottom end. Hopefully I'll have that timing chain in a few days. And then of course we have to set up the heads and put them together and degree the cam. So I am grateful that you are watching. And stay tuned. I will talk to you very soon, I promise.